Bismillahirrahmanirrahim. We will start with quote of the day. Ramadan is the best time to make or break a habit. I'm Dr. Taimia Ayub, and today I will be presenting the topic of demography under the supervision of Professor Dr. Saira Afzal, Dean, Institute of Public Health, Lahore. These are the learning outcomes of today's class. This is the outline of today's presentation. We will start with the demography and the key definitions. Then we will cover the concept of population doubling time, importance of demography, population pyramids, and their examples. And at the end, we will cover some population theories and do some multiple choice questions. So, what is demography? Demography is the scientific study of human populations encompassing their size, composition, distribution, and the dynamic processes that change them, including births, deaths, and migration. The word derives from the Greek demos, stands for people, and graphene to describe or write. Formal demography focuses on mathematical and statistical methods to measure population change, fertility rates, mortality rates, migration flows, and population predictions. Social or population studies examines the social, cultural, economic, and political determinants and consequences of demography change, broader and more interdisciplinary. So, what is the scope of demography? Demography covers mainly the questions of how many, like the people's population sizes, how many people live in a region, country, or the world at a given time. Who? What is the population composition? Breaking down it by age, sex, ethnicity, education, occupation, and other characteristics. Where? Population distribution, geographic spread, urban versus rural, density, and settlement patterns. And finally, why it is changing. Demographic processes, fertility, births, mortality, like deaths, and migration that drive the population change. Now we'll come to cover some key definitions. So, core demographic terms include population, the total number of individuals inhabiting a defined geographical area at a specific point in time. Fertility, the actual reproductive performance of a population measured by the number of live births. Mortality, the incidence of death in a population during a given period expressed as a rate per thousand persons. Migration, the movement of people from one place to another with intent to settle temporarily or permanently. Birth rate or crude birth rate, the number of live births per thousand population in a given year. The main formula is births divided by median population into 1000. Then we have death rate, particularly crude death rate, which is the number of deaths per thousand population per year. Similarly, according to the birth rate, the death rate formula is deaths divided by median population multiplied by 1000. Natural increase rate, the difference between the birth rate and the death rate. Crude birth rate minus crude death rate represents population change excluding migration. Then we have net migration rate, the difference between immigrants and emigrants per thousand population. Positive is equal to net in migration, negative is equal to net out migration. Then we have term like total fertility rate, average number of children a woman would have over her lifetime given current age specific fertility rate. If the total fertility rate is more than 2.1, it is above replacement level. But if it is 2.1 or less than 2.1, then it is below replacement level, meaning that the older generation is not being replaced by the new borns, which are babies which are being produced. Life expectancy at birth. The average number of years a newborn is expected to live, assuming current age specific mortality rates remain constant. Then we have infant mortality rate, death of children under 1 year of age per thousand live births, a key indicator of health system quality and population health status. Then we have under 5 mortality rate, death of children under 5 years per thousand live births, widely used as a composite index of child health and socioeconomic development. Then we have a dependency ratio, which is the ratio of dependent age 0 to 14 years and 65 years and above to the working age population, which is between 15 to 64 years of age. If it is high, it means that great economic burden on the working adults. Then we have age specific rate, demographic rates like births, deaths calculated for specific age groups rather than the whole population, allowing more precise comparison. We have population growth rate, the rate at which population changes in size per year expressed as a percentage, includes natural increase and net migration. And finally, we have sex ratio, number of males per 100 females in a population. Deviations from the expected ratio, 105 males per 100 females at birth, signal demographic or social issues. So now we come to another important concept, which is the concept of population doubling time. Population doubling time is the number of years it would take a population to double in size, assuming a constant annual growth rate. Why does it matter? It gives a tangible sense of how fast a population is growing, helps planners estimate future demands for food, water, housing, and health services, guides resource allocation in low and middle income countries like Pakistan, highlights urgency when growth rates are high, small rate differences lead to large long term differences. This is the formula to calculate the population doubling time, which is the rule of 70. A doubling time is equal to 70 divided by R, where R is the annual population growth rate in percent. Why 70? The number 70 is derived from the natural logarithm of 2 into nearly which is equal to 70 by 100, which is the mathematical basis for the exponential doubling. So the growth rate, if it is 1%, then the doubling time is 70 years, for example, in Sweden or Germany. If the growth rate is 2 years, 2%, the doubling time is 35 years, like in India in early 2000s. If the growth rate is 2.4%, doubling time will be 29 years, for example, currently in Pakistan. If the growth rate is 3%, the doubling time will be 23 years, which is the case in sub-Saharan countries. So we divide 70 by the whatever the annual growth rate is, and then we will arrive at the doubling time. So Pakistan population growth rate is 2.4% per annum in 2023. Calculate the doubling time and project the future population. The step one is to identify the growth rate, which is the 2.4. Then apply rule of 70, dividing 70 by 2.4. It comes out to be 29 years. Then we have current population, which is about 2.230 million, and projected population by 2052 is 460 million. So we are doubling the 230 to 460. So the public health implication is that Pakistan must double its hospitals, schools, water supply, and food production within a generation to meet the demands of this doubling of its population. So now we come to another important example, which is that of importance of demography in public health. So, why demography is central to the concept of public health? Demographic data is the foundation upon which all public health progress. Upon which all public health action is built. It identifies health needs. Age, sex, structure reveals who needs what services. MCH care for a younger population, geriatrics care for aging ones. For example, guides resource allocation, population size, and growth determines how many health facilities, bed, and health workers are required. It helps in designing intervention. Disease burden varies by age, sex, and geography. Demographic data allows targeted, cost effective programs. It monitors progress, tracking IMR, MMR, life expectancy, and fertility over time, gauges where health programs are working. It forecasts disease burden. Population projections help anticipate future burdens of NCDs, emerging infections, and mental health needs. It informs health policy. Government budgets, health workforce planning, and insurance schemes are all grounded in demographic projections. So now we come to demographic structures and disease burden. For example, in case of Pakistan, the majority is younger population. So there is high demand for maternal and child health services. Vaccine preventable disease burden is very high, and that's why vaccination is very important. There are many nutritional deficiencies like stunting and wasting in children in Pakistan. There are enormous reproductive health needs. School health programs are essentially needed, and large adolescent health burden is there. But in case of Europe or Japanese population, which are more of aging population, there is more risk of non-communicable diseases, cardiovascular, cancer, and diabetes burden are increasing. Long-term care and dementia services are needed there. Polypharmacy challenges, pension and social security strain, and shrinking workforce in health sector. So this is a quick comparison between a younger population and their demands and the aging population and their demands. Although there can be overlapping of the needs. Pakistan's demographic profile at a glance, there are about 240 million population in Pakistan. The annual growth rate is 2.4%, total fertility rate is 3.3%, and life expectancy is birth is 68 years. 64% of population is under 30, one of the youngest populations in the world. Dependency ratio, 64 dependents per 100 working age adults, significant economic pressure. Urban population has grown from 32% to 38%. Rapid urbanization trends are being seen. Maternal mortality ratio is 186 per 100,000 live births, which is highest among in South Asia. Pakistan demographic window of opportunity youth pulse will last approximately until to 2045, and this is the time period for Pakistan to make a use of this younger generation and their and its workforce. So demographic data and public health planning. So at number one, we have census and vital registration. Census data and civil registration, births, deaths are the primary sources. Pakistan last census was done in 2023, which was the first digital census in Pakistan. Civil registration remains incomplete in rural areas and even in some parts of urban areas. Health service like demographic health service and mix. Pakistan Demographic and Health Service and Mix provide age, sex stratified health data for programs planning at district level. Then we have disease surveillance. Linking disease surveillance data with demographic data identifies high risk subgroups, enabling targeted prevention strategies. Then we have health workforce planning. WHO recommends 4.45 health workers per thousand population. Pakistan currently has 1.4, which is very low, and demographic projections can plan help in training and planning. Now we come to another important concept of in demography, which is that of population pyramids. What is population pyramid? A population pyramid is a back-to-back bar chart that shows the age and sex distribution of a population at a given point in time. Males are plotted on the left side and females on the right side. Each horizontal bar represents a 5 years cohort. For example, 0 to 4 years, 5 to 9 years, and so on. Width of bar represent either the absolute number or the percentage of the total population. The overall shapes reveal the demographic stage and trajectory of the population. Provides an instant visual snapshot, no tables or formulas needed to detect the patterns. It is most useful when comparing across time periods or between countries. So we have the components of a population pyramid. On the x-axis, we have horizontal component which represents the number or percentage of population in each age sex group. On the left side, we have male, and the right side, we have females. On the y-axis, vertical axis, we have age groups which are arranged from youngest at the bottom to oldest at the top, and usually they are in 5 years cohort, but it can be different also. Then we have age cohorts which are in the form of bars. Each horizontal bars, as explained, represent 5 years old group. Then on the left side, we have male, which are shaded usually in one color, typically blue. Long bars at the bottom shows high fertility countries. And then on the right side, we have female, which are shaded in another color, typically red or maroon. Female bars usually extend further at older ages due to longer life expectancy. And then we have dependency group, which are the young dependents at 0 to 14 years at base, and the working age, then we have between 15 to 64 years of age in the middle, and the early dependents, which are at 65 years and plus at the apex. So there are three main types of population pyramid. We have expansive pyramid, which has wide base, rapidly narrowing to apex, which represents high birth rates, high death rates historically, rapid population growth, and large youth population. For example, in Pakistan, Nigeria, Afghanistan, and so on. Then we have constructive of or bell-shaped, which are shaped narrow base, then middle sections, which shows declining birth rates, aging population, slower growth rate or stable, and increasing dependency ratio, which is in USA and Australia. The examples are. And then we have stationary or column, which is roughly equal width at all ages, which represents low birth rates, low death rates, near zero growth, and high life expectancy, which is the case in Germany, Sweden, and Japan. So these are some important tips of how to read the population pyramid. It is to look at the base. First of all, see if the base is wide, which shows high fertility and high proportion of the children. Then examine the middle portion. The width of the working age cohort 15 to 64 determines the demographic dividend, economic productive capacity relative to dependent. And Pakistan is currently having a very good demographic dividend. Then we have to study the apex. If the apex is broad, large elderly population. If the apex is narrow, it shows high premature mortality. Then compare male versus female. Long female bars at older age are expected. Anomalies, for example, excess male deaths may indicate conflict, occupational hazard, or emigration. Then look for notches. Indentation in specific cohorts may reflect historical events, for example, epidemics, wars, baby booms, or migration waves. And then compare them over time. Pyramids for different years reveal population aging, fertility decline, and success or failure of population programs. So now we see some of the examples. So we have expensive pyramid, and in these expensive pyramid, we have wide base and rapid narrowing at the upper side, which shows high fertility, fast growth, and the examples are of Pakistan, Nigeria, and Afghanistan, and they are nearly showing typical same age, um, same shaped pyramids, and we have a wide base and then tapering down till the bottom. Then we have constrictive pyramid, which are narrower base, bell-shaped, declining fertility, and transitional growth. For this, we have examples of Brazil, India, and China, and you can see that they are honeycomb shaped. This is also the other name. And their total fertility rate is usually 2 or below 2, and they are having this cylindrical shape. Then we have stationary pyramids, and for that there is uniform width, column shaped, very low fertility, near zero growth or decline. And these are examples of Germany, Japan, and Sweden, which have similar shape, which is the rectangular shape, and they are having very low fertility rate. So this is the example of Pakistan. It is an expensive pyramid. It is very wide based, high fertility rate of 3.3, rapid narrowing, high child mortality. Historically, large youth bulges are seen in 0 to 24 years, which is about 20-50% of the population. Narrow apex, which shows premature adult mortality. Potential demographic dividend if youth are educated and employed. High demand for schools, vaccines, and MCH services are there. Again, we have the example of Japan, which is an inverted or stationary pyramid. It has narrow base because there is very low fertility of 1.2 in Japan. Broad apex is there, which shows highly aged population. Inverted shape, top is heavy, the bottom part is lighter or narrower. And these are some of the examples. And the light brown side is showing the female side, the dark brown is showing the male side. And as you can see, the 5-year groups are going up. So importance of population pyramids in public health is that of health service planning, disease burden prediction, workforce projections, reproductive health programs, immunization planning, and monitoring SDG progress. So now we come to population theories. There are some theories. I will be discussing some of them. Major theories explaining why population grow, stabilize, or decline, and their public health significance. For that, we have first of all Malthusian theory, which was given by Thomas R. Malthus in 1798. Then we have Borsrup theory, which was given by Esther Borsrup in 1965. Then we have Neo-Malthusian theory, which was given in late 1960s. And then we have demographic transition theory and epidemiological transition theory. The demographic transition theory and epidemiological transition theory, these theories and their phases, they will be explained by in tomorrow's lecture. And today I will be covering the Malthusian and the New Malthusian theory. So Malthusian theory is says that the power population is indefinitely greater than the power in the earth to produce subsistence for man. So the core argument is that the population grows geometrically and the food grows arithmetically. And this leads to an inevitable gap which becomes a crisis. So preventive checks are there that there should, if there are delayed marriages, celibacy, moral restraint, reduced birth, then these things can be prevented. Positive checks are there: famine, disease, war, raise deaths when population exceeds food supply. According to public health relevance highlights link between population pyramid, malnutrition, and infection disease burden in lower middle income countries. Then we have Borsrup theory, which was given by Esther Borsrup in 1965. It says that effect of an increase in population on agricultural development is one of the stimulus rather than one of the hindrance. The core argument is that the population pressure stimulates agricultural innovation. People find solutions when they are forced to. In the contrast with Malthus, Malthus saw population as a problem. Borsrup saw it as a driver of progress and productivity. And the key mechanism is that if there are more mouths to feed, there is intensified farming, new technology, higher yields, and food for all. So the public health relevance is that it supports investment in human capital, education, and health create the innovators who solve resource problem. So this is the Borsrup virtuous cycle, which says that if there is food shortage, it leads to innovation and intensification, which leads to increased food supply, and there is population growth, which leads to again then the food shortage. This is the it goes in circle. And finally, we have newer Malthusian theory, which is given in late 1960s, and it said that the battle to feed all of humanity is over. In the 1970s, hundreds of millions of people will starve to death. The core argument is that updates Malthus, even if foods keep pace, population growth exhaust water, energy, land, and climate stability. And it differs from Malthus, explicitly supports contraception and family planning, unlike Malthus, who oppose it on moral grounds. And the public health relevance was that justifies family planning programs, reproductive health services, and population policies in lower middle income countries like Pakistan. So this was the equation which was given, which was the IPAT. I is equal to impact, which P is equal to population. A is affluence per capita per consumption, and T is the technology, which is the resource used per unit output. So these are some of the key takeaways. Is that demography is the scientific backbone of public health. The rule of 70 give a quick, powerful estimate of how past populations grow. Pakistan's 2.4 growth rate means it could reach 460 million people within 30 years. Population pyramids are visual diagnosis. They instantly reveal health needs, workforce capacity, and development stage. An expensive pyramid signals high MCH needs. A stationary pyramid signals NCD and elderly care challenges. Demographic literacy is non-negotiable for public health leaders. Use data to advocate, plan, and act. So now we come to multiple choice question portion of the presentation. So for that, we have the first MCQ. A district health officer observes that the number of live births in district was 18,000 during a year, and the median population was 900,000. Which demographic indicator can be calculated directly from this information? Age-specific fertility rate, net reproduction rate, total fertility rate, general fertility rate, and or crude birth rate?
E.
Yes, E is the answer. Pakistan's population growth rate is approximately 2.4 per year. A public health planner wants to estimate approximately the number of years it will take for the population to double using a quick demographic rule. Which approach should be used? Divide 70 by the annual growth rate, multiply growth rate by life expectancy, divide 100 by the annual growth rate, multiply the growth rate by fertility rate, or subtract death rate from the fertility rate.
A.
A.
Yes, it is A is right. Now we come to next. Which demographic indicator is most useful for assessing the long-term reproductive behavior of women in population independent of its age structure? Crude birth rate, net migration rate, infant mortality rate, total fertility rate, or population growth rate?
A.
For this, the answer is delta. Next MCQ is that a country's population pyramid shows a broad base, rapidly narrowing middle, and very small apex. From a public health planning perspective, which health priority is most consistent with this demographic structure? Expansion of geriatric and palliative care services, increased focus on maternal and child health programs, expansion of chronic disease rehabilitation centers, investment primarily in long-term dementia care, or reduction in immunization structure.
B.
Yes, it is B, increased
B.
focus on maternal and child health programs. Which demographic indicator specifically reflects the balance between population inflow and outflow due to migration? Population growth rate, natural increase rate, crude birth rate, net migration rate, or dependency ratio?
D.
So the answer is D, net migration rate. And then we have next MCQ, a demographer examining Pakistan population notes that 64 dependents exist for every 100 working age adults. Which indicator best represents this situation? Age specific mortality rate, crude dependency ratio, population density, life expectancy at birth, or sex ratio?
B.
B.
Yes, it is B, crude dependency ratio. The next MCQ is a population pyramid of a high-income country shows nearly equal width across most age group with a relatively large elderly population. Which demographic stage does this most closely represent? Stationary pyramid, constrictive pyramid, expansive pyramid, transitional pyramid, or inverted pyramid?
A.
Yes,
E.
it is a stationary pyramid because it is nearly equal widths across most age groups, so it is stationary. Now, the next MCQ is a provincial planning department estimates that the population of a rapidly growing city is increasing at 3% annually. Using the rule of 70, approximately how long will it take for the population of the city to double if the growth rate remains constant? 18 years, 35 years, 29 years, 23 years, or 47 years?
D.
It is, yes, it is delta.
B.
Delta, we will divide 70 by 3. So the answer will come out to be 23 years nearly. A demographer calculates that the population doubling time of a country is approximately 35 years. Assuming exponential growth and using the rule of 70, what is the annual population growth rate? 2%, 1.5%, 0%, 2.5%, or 3%?
D.
So in this case, it is alpha 2%. So we will multiply 35 by 2 and it will come down to be 70. So we will do it reverse. So it is a alpha 2%. This is the answer key. This is the YouTube link where this video will be uploaded. And thank you very much for listening.
Thank you